Hey everybody, so one of our first tasks this year is to be able to put numbers in order from least to greatest, or at least know where numbers go on the number line. Is one farther to the right or farther to the left? And that seems simple enough, but today we're going to talk about how to do that with decimals, right? Before we start talking about decimals though, let's just take a look at how they're different from whole numbers. Let's say you have a number like 26 and a number like 25, and I ask you which one is greater. Well, it's pretty obvious that 26 is the greater number. So one of the ways you know that is that you start at the greater place value. Start looking here and say, okay, this number has two groups of 10, and this number has two groups of 10. So far, they're even. And then you look at the next smallest place value. This one has 6 groups of 1, and this one has 5 groups of 1. So this one has more groups of 1, right? An equal group of 10, but more 1, so that makes it a greater number. The problem is when we look at decimals, we don't always know which place value is bigger or smaller. So that's what we want to talk about today. So take a look at this, 3/10 versus 5/100. Now you might just assume that 5/100 is the greater number because, well, 5 is bigger than 3, but we forgot about place value, right? So maybe that's not true. So we're going to start off by just thinking about these as fractions for a second. Let's take a look at 3/10. Normally we would write 3/10 as, well, 3 over 10. And we'd think of 5/100, this is the hundreds place, as 5 over 100. Now you might look at this and say that doesn't help me tell which one is bigger, but I want you to think about how you make fractions equivalent. Right? So what we're going to do is we're going to make a common denominator, and then it will be easier to compare them. So I'm going to take this 10 and I want to change it to 100, so they both have 100 as a denominator. I'll multiply the bottom by 10 and the top by 10, and what I end up with is 30 hundredths. And now we can I want to say it's easier or more easily tell that this number is greater. How many hundredths does this one have? 30. How many hundredths does this one have? 5. So what we can say is that 30 hundredths is greater than 5 hundredths. If you think about those as pennies or cents, 30 cents is greater than 5 cents. So this number is greater. 3/10 is greater than 5 hundredths. Now, that's the way you want to think about it, but an easier way to just show it is to just show the additional place value. For example, I would write this as 3/10, and if I was comparing it to 500ths, let me rewrite this here, 0 and 0 and 5, what I would do is I would just, let me get a different color here, I would just show the hundredths place in this number, 3/10. How many hundredths are there? Well, there are none. That's why it wasn't showing in the first place, because there were none there. But whenever there's nothing in a place value, I can always replace that nothing with a 0. And that makes it easier for me to compare 30 hundredths compared to 5 hundredths. Okay, 30 hundredths is more. What we're really doing is we're changing 3/10 into 30 hundredths. Those are equivalent values. All right, let's take a look at one that's a little more complicated. Here I have 1 and 23 hundredths, and here I have 1 and 93 thousandths. This number, 1 and 93 thousandths, looks like it must be bigger. It has 1, 2, 3, 4 digits in it. This one only has 3 digits in it, and so it looks smaller. But we want to check, right? So I'm going to write this as a fraction. It's 1 and 23 hundredths. I'm going to write the other number as a fraction. 1 and 93 thousandths. Okay, so again, it doesn't really help initially, right? We still, fractions are just as confusing as decimals, right? So what we're going to try and do is we're going to change this fraction so that it has the same denominator as the other fraction. 100 times 10 will equal 1,000. So how many thousands do we get? Well, 23 times 10, I hope you realize when you multiply something by 10, you're just going to add an additional place value at the end. 23 with a 0 on the end, that's multiplied by 10. 230 thousandths versus 93 thousandths. Now, remember, they both have 1, right? So the 1's place isn't different. So then we're going to look at the next place values. We have 1 and 230 thousandths versus 1 and 93 thousandths. So this number is greater. This number is greater. So that's how we should be thinking about it, right? We made an equivalent number, 230 thousandths. What would that look like as a decimal? Well, it would look like this, 1 and 230 thousandths versus the other number, 1 and, oh, let me get that to be green, 1 and 93 thousandths. You see, all we did is we just revealed this extra place value, the thousandths place. We made an equivalent fraction, right? It used to be 23 hundredths, but when we showed that extra place value, it became 230 thousandths. And you can just look, 230 is greater than 93. Done. Right, let's do one more quick example here. What if you're asked to put three numbers in order? Well, we're going to try and mix these two ideas that we had. These show us three numbers. We've got 2 tens, 2 tens, 2 tens. Okay, they're all very similar. We have 4 ones, and this one has 5 ones. Okay, so 25 is greater than 24. Greater than 24. So I would say that 25 and 9 tenths is the greatest number. All right, let's start looking at other place values. This one has 9 tenths, and this one has 0 tenths. So it looks like this one will be greater, right? We know that 9 tenths is greater than 0 tenths. So let's write that one down. We've got 24 and 9 tenths. And that would, of course, leave the purple one here as the greatest, well, the least number. I'm actually writing these in reverse order from greatest to least. 24 and 9 hundredths. 24 and 9 hundredths. Now, I'm just going to go back and I'm going to make them all into a common denominator. I'm going to show them, make them all have a hundredths place. And we should see what they look, that our previous strategy of just looking at the common denominator should still work. Right? So this looks like 25 and 90 hundredths. This looks like 24 and 90 hundredths, right? 25 is more than 24. And this one looks like 24 and 9 hundredths, right? So 25 is greater than either of these, and 90 hundredths is greater than 9 hundredths. Okay, so showing those empty place values gives us a common denominator. I hope that helps.